Good morning all. Today we are going to discuss about our third unit. The name of the unit is transactions. The portions we are going to cover are transaction concepts, asset properties, what do you mean by a schedule, need for concurrency control, what are all the concurrency control techniques, deadlock and recovery, and finally a case study regarding IRCTC website working model as a transaction processing. Okay. So what do you mean by transaction? A transaction is a collection of operations that form a single logical unit of work. This single unit of program executes and accesses several data. Example, let us assume a transfer of $50 from account A to account B. So the list of operations to be carried out for these transactions are: first one, the initial account balance of A has to be read out, and then $50 will be deducted from A and the balance will be updated. Similarly, the initial balance of B has to be read out, $50 will be credited to B and the final balance will be updated. The main issues during the transactions may be occur due to hardware failures or system crashes or some anomalies due to concurrent executions of multiple transactions. So for a successful transaction to take place, it has to satisfy some requirement. The requirements are: first one is atomicity requirement. What is atomicity requirement? If the transaction fails at 3 and before step 6. So step 3 is write of A. Step 6 is write of B. So if some problem occurs in between these two steps, money will be lost. That means money will be A, but it will not be credited to B. So this led to an inconsistent data. That is called durability. Durability means once the user has completed the transaction, it will be updated to the database even after hardware or software failure. That is called durability requirement. Third one is consistency requirement. Consistency requirement is the sum of A and B is unchanged. But let us assume the initial balance of account A is $300 and the initial balance of account B is $200. So the sum of A and B is 300 plus 200 is equal to $500. Okay. So let us assume a transaction of $50 from A to B. So after the transaction, the balance of A is $250 and the balance of B is 200 plus 50. So $250. So the sum of A and B is 250 plus 250 is $500. So the sum of balance of A and B before the transaction is $500. After the transaction is $500. That is called consistency. Okay. Last one is isolation requirement. If any other database access the data in between the steps 3 and 6. What is step 3? Writing of A. Step 6, writing of B. So if any other database access the data in between the two steps, it will lead to an inconsistent database. Okay. So that is solved by isolation. Okay. So for a transaction to be completed successfully and to preserve the integrity of data in the database, the system must ensure 4 properties. What are they? Atomicity, consistency, isolation and durability. These four are together called as acid properties. A for atomicity, C for consistency, I for isolation, and D for durability. Okay. So for a successful transaction to take place in a system, the system should ensure acid properties. Okay. The transactions can be either in the 5 states during execution. First one is initial state is active state. Okay. Partially committed means after the final statement has been executed, it will be in partially committed state. If any failure occurs during the transaction, it will be in the failure state. So it has to be rolled back. So it will be aborted and rolled back to the previous state. Okay. If any problem doesn't occur and the transaction completed successfully, it is called committed state. So these are the various states in the pictorial representation. Initially in active state. After that, it will be either in partially committed state or failed state. Okay. After partially committed, it will go to the committed state, or it may fail. It will come to failed state. If the transaction fails, it has to finally go to aborted state. Okay. If the transaction completed successfully, it will go to committed state. So these are the 5 states of a transaction. Concurrent execution. What do you mean by concurrent execution? Doing multiple transactions at the same time in a single database. That is called concurrent execution. So the advantages of concurrent execution are we can increase the processor and disk utilization. So we can get a better throughput and reduced average response time. Okay. But we have to follow several mechanisms for concurrent executions to be successful. Schedule. What is a schedule? A sequence of instructions that specify the chronological order in which the instructions of concurrent transactions are executed is called a schedule. For example, if there is more number of transactions occurring in a single database, we must have a schedule. So schedule is nothing but which transaction is to be first executed, followed by which transaction, and finally what will be the output of the database. That is called a schedule. So a series of operation from one transaction to another transaction is known as schedule. So schedule is used to preserve the order of operation in each of the individual transaction. So this is the diagrammatic representation of types of schedules in DBMS. Schedule divided broadly into serial schedule and non-serial schedule. Serial schedule means the number of transactions occur serially, that is after completion of first transaction, the second transaction will start. Of second transaction, the third one will start. That is called serial transaction, serial schedule. Okay. So there will not be any problem in a serial schedule. The next type is non-serial schedule. Non-serial schedule, that it can be further classified into serializable schedule and non-serializable schedule. So even though the schedule is a non-serial one, if it can be serializable, then we can execute in concurrency without any problem. So serializable schedule can be classified into conflict serializability and view serializability. Non-serial schedules can be categorized as recoverable schedule, non-recoverable schedule. Recoverable schedules are again classified into cascading, cascadeless, and strict schedules. So we will discuss about the types of schedules in detail. So serial schedule is a schedule in which the transactions are executed non-interleaved. That is one after the another. So there is no problem in serial schedule. Non-serial schedule means it's a type of scheduling where the operations of multiple transactions are interleaved. It means during the transaction 1, transaction 2 may start or transaction 3 may start executing like that. Okay. So in a non-serial schedule, the other transaction proceeds without waiting for the previous transaction to complete. So this sort of schedule does not provide any benefit of the concurrent transaction. A non-serial schedule can be classified further into serializable schedule and non-serializable schedule. Serializability. Serializability means a schedule is serializable if it is equivalent to a serial schedule. For example, a non-serial schedule, if it can be converted to a serial schedule, it is called serializability. The two different forms of serializability is conflict serializability, view serializability. So conflicting, before going to the types of serializability, we will discuss what are called conflicting instructions. Instructions, we can easily come to a solution that a given schedule is serializable or not. Okay, so let us assume I and ij are the two instructions of a transaction. Okay, so ia is an instruction of transaction ti and ij is an instruction of transaction tj. Okay, instruction I and ij are called conflicting instructions if they follow any one of these. First one is if ii is equal to read of q and ij is also a read of q. So if when both are reading, it will not conflict. And read the data at a single time. There will not be any problem. Okay, but one transaction is reading the data and another one is writing the data, means that is called conflict. For example, ia is read of q and ij is write of q. They conflict. Third one, ia is writing of q and ij is reading of q. That will be led to conflict. Fourth one, both are writing. So that there will be a conflict. Okay. If ia and ij are consecutive in a schedule and they do not conflict, the results will remain the same even if they have been interchanged in the schedule. Okay. So if a schedule S can be transformed into a schedule S dash by a series of swaps of non-conflicting instructions, we say that S and S dash are conflict serializable. Okay. If the if the S and S dash is equivalent, then it is called conflict equivalent. So let us consider the example of schedule 3 and schedule 6. So schedule 3 can be transformed into schedule 6, that is a serial schedule where T2 follows T1 by a series of swaps of non-conflicting instruction. Therefore, schedule 3 is conflict serializable. Example of a schedule which is not conflict serializable, T3 and T4. So here we are unable to swap the instructions in the above schedule. So T3 comma T4 or the serial schedule T4 comma T3. So we are not able to swap the instructions. So this is not conflict serializable. So the conflict serializability can be easily identified by drawing a precedence graph. Precedence graph is a direct graph where the vertices are the transaction names, and we can draw an arc from one transaction to another if the two transactions conflict and TI access the data item on which the conflict arose. For example, the diagram T1 to T2, there is an arrow mark. It means T1 to T2 conflict and T2 to TI also conflict. Okay, if there is any cycle in the graph, we can say that it is not conflict serializable. If there is no cycle in the graph, then the schedule can be conflict serializable. So this is the process. First one, testing for conflict serializability. If the schedule is called conflict serializable. Okay. So if precedence graph is acyclic, the serializability order can be obtained by drawing a topological sort of the graph. If there is cycle, then we cannot serializable the schedule. Okay. So there are two ways. If there is no cycle, it is conflict serializable. So we can draw the topological sort of for the graph. That is the order of execution of the transactions. If the precedence graph has cycle, then the graph will not be conflict serializable. So we should not execute the transactions serially. Okay. Then recoverable schedule. Recoverable schedule means if a transaction Tj reads a data item previously written by another transaction Ti, then the commit of Ti must appear before the commit of Tj. That is called recoverable schedule. Example T8 and T9. So T8 writing and T9 is reading the data. So T9 should commit before T8. That is called recoverable schedule. Cascading rollback. A single transaction failure leads to a series of transaction rollbacks. So rollbacks is nothing but going to the previous state of the transaction is called rollback. So if T10 fails, in the above example, we are considering three transactions, T10, T11 and T12. If T10 fails, T11 and T12 also rolled back. So this will lead to undoing a significant amount of work. So we should design a database that needs only a minimal rollbacks. Okay. So cascadeless schedule. For each pair of transaction Ti and Tj such that Tj reads a data item previously written by I, the commit operation of Ti appears before the read operation of Tj. This is called cascadeless schedule. Cascadeless schedules can also be recoverable. It is desirable to restrict our schedules to cascadeless. Okay. So this is the diagram which is a not cascade schedule. Then the next topic we are going to discuss is concurrency control. What is concurrency? We have to execute more than one operations at a single time. So while executing more than one operation concurrently, we have to follow some procedure for controlling the concurrent execution so that it will not lead to a database to a inconsistent state. Okay. So there may be some problems that occur during concurrent execution. So these we will follow one by one. We will discuss one by one. That is the problems that may occur during a concurrency execution. The problem is dirty read problem, that is called write read conflict. The dirty read problem occurs when one transaction updates an item of the database, but the transaction fails before the data gets rolled back. So the updated data items is accessed by another transaction. There comes the read-write conflict. Let us consider the example. It has two transactions Tx and Ty. It performs the operations read and write on account A, where the available balance of account is $300. Okay, in time T1, read of A will be performed by transaction Tx. So the initial balance of A will be read out and then it is incremented by $50 and then it will be updated. So write of A. After that, the updated value of A will be read by the transaction Ty. Okay. Now the server rollback occurs. Server rollback occurs in transaction Tx. It means that the A will get the previous value. Okay. But Y already reads the updated value of A. That is called dirty read problem. Next problem is problem. It is also known as inconsistent retrieval problem that occurs in a transaction when two different values are read for the same database. So for example, let us consider the table in which Tx and Ty transactions are involved. At time T1, A will be read by transaction Tx. At time T2, A will be read by transaction Ty. And A will be incremented by 100 by Ty. And the updated value will be written by Ty. And after that, at time T5, again the transaction Tx reads A. Now the data will be updated. So that is called unrepeatable read problem. Do no work in A. At time T1 it reads A. At time T5 it reads A. But there is a change in A. That is called unrepeatable. So in order to avoid these problems, we can use some techniques. They are called concurrency control techniques or concurrency control protocols. So these are executed to ensure the asset properties of the transaction. So first protocol is log-based concurrency control protocol. Next, timestamp-based concurrency control protocol. Next one, validation-based concurrency control protocol. So regarding the exam point of view, concurrency control protocols are very in detail about each of the concurrency control protocol. First one, log-based concurrency control protocol. In this type of protocol, any transaction cannot read or write data until it writes an lock. So the transaction has to first acquire a lock and then it can start. So there are two types of lock: shared lock, exclusive lock. Shared lock is called read-only lock. In a shared lock, the data item can only be read by the transaction. The transaction cannot perform any write operations. So in an exclusive lock, the data item can both be read as well as written by the transaction. This is an exclusive one, so multiple transaction cannot acquire this lock at the same time. So there are four types of lock protocol. First one, simplistic lock protocol. It is this very simple method. It allows transaction to get the lock before insert or delete or update the data. It will unlock the data after completing the transaction. Next one is pre-claiming lock protocol. So it evaluates the transaction to list all the data items on which they need lock. So for a transaction, let us assume if the transaction is going to use the value A, B and C. Okay, to access the value A, B and C, the transaction S has to first acquire the lock of A, lock of B and lock of C. After acquiring the locks, the transaction can begin. Or once the transaction is completed, all the locks will be released. The third one is two-phase locking protocol. So this is a very important locking protocol. So here let us discuss the diagram. So look at the diagram. In the first part, when the execution of the transaction starts, it seeks permission for the lock it requires. So in the second part, the transaction acquires all the locks. The third phase is started as soon as the transaction releases the first lock. Okay, so in the third phase, the transaction cannot demand any new lock. So it first, for example, a transaction X needs the data A, B and C. Okay, so it requests for lock on A, B and C. Okay, on availability, it can be start the execution. Once it start releasing any one of the lock, after its usage, it can any new locks. Okay, that is called two-phase locking. So in the two phases in this protocol, growing and shrinking phase. Growing phase means, so the data, the transaction X has requested for 3 locks, lock A, B and C. So acquiring one by one lock is called growing phase. Okay, and then after the transaction is completed, the lock will be released one by one. That is called shrinking phase. So upgrading of locking is allowed in growing phase. Downgrading of lock is allowed in shrinking phase. So next one is strict two-phase locking. So it is somewhat similar to that of two-phase locking. The first step is same. Then the only difference is the strict two-phase locking does not release a lock after using it. It has to wait for the entire transaction to complete. After the transaction has committed, it releases all the locks at the same time. So it does not have shrinking phase. It has growing phase and then execution phase. Once the transaction executes completely, it gets committed, and after the completion, it releases all the locks at the same time. Okay, so there is no shrinking phase here. Okay, after concurrency control, we are going to discuss about serializability. So in serial schedule, no concurrency allowed. So there is some difference between serial schedule and serializable schedule. Serial schedule means no concurrency allowed. Serializable means concurrency allowed. Serial schedule means no concurrency means less resource utilization and less CPU throughput. Serializable means we can improve the resource utilization and CPU throughput. Serial schedules are less efficient compared to serializable schedule, whereas serializable schedules are always better than serial schedules. Conflict serializability. If a given non-serial schedule can be converted into a serial schedule, so what is conflicting operations? Two operations are called conflicting operation if the two conditions satisfied. First one, both the operations belong to the different transaction. both the operations are on same data item, at least any one of the operation is right. Okay, that means operations that belong to two different transactions operating on a same data, out of which one is right. That is called conflicting operations. Example, let us consider the transaction T1 and T2. So the data A, same data item A. So transaction T1 is also operating on A, T2 is also operating on A. So consider the transaction W1 of A and R2 of A. So these two are called conflicting operations. Why? Because both are belonging to different transaction. Both are using the same data item A. One is write, one is read. So that is called conflicting operations. Okay. So we have the next one is checking whether a schedule is conflict serializable or not. So this kind of problem can be asked in a part C question. A schedule can be given. A schedule may be given. We have to apply the 4 steps and we have to check whether the schedule is conflict serializable or not. First one, we have to list out all the conflicting operations. What is a conflicting operation? If two operations belonging to two different transactions using the same data item, out of these one is right operation, then it is called conflicting operations. So first we have to list out all the conflicting operations. Second one, we have to draw a precedence graph for each transaction. Third one is how to draw edge in a precedence graph. Every transaction is a node. So the edge will be drawn from one transaction to another if xi of v and yj of v forms a conflict pair. Then we will draw a edge from ti to tj. Okay. So after drawing all the cases, that is all the pairs in the precedence graph, then we have to check if there is any cycle in the precedence graph. If there is no cycle, then the schedule can be conflict serializable. If there are any cycle in the graph, then it is not conflict serializable. So these are the steps. We have to follow all these 4 steps to ensure whether a given schedule is conflict serializable or not. We have to list out all the conflicting operations. Second one, we have to draw a precedence graph. That is, in the precedence graph, that every node is a transaction and the edge will be drawn according to the conflicting instruction. Then if there is any cycle in the graph, then we can determine that the schedule is not conflict serializable. So let us consider the example. The schedule is read 1 of A, read 1 of B, read 2 of B, read 3 of B, write 1 of A, write 2 of B. First we have to step out the conflict, determine the dependency between the transaction. So here R2 of A, so first R1 of A and R2 of A, both are read, so no conflict. Then R2 of A, R1 of B, no conflicting. R2 of A and W1 of A is conflicting, and then R1 of B, W2 of B conflicting. R3 of B, W2 of B. So there are three conflicting instructions. So after listing out the conflicting operations, we have to draw the precedence graph. So the transactions are T1, T2 and T3. So we have to draw the graph T1 to T2. Why? T1 to T2 means the second conflicting operation R1 of B and W2 of B. So T1 to T2. Okay. Then T3 to T2. The third operation, that is R3 of B and W2 of B. And then the conflicting operation R2 of A and W1 of A. So there is a edge from T1 to T2. So T1 to T2, T2 to T1. So there is a cycle. Okay. So the graph is not, the schedule is not conflict serializable. Okay. Since there is a cycle in the precedence graph, the schedule is not conflict serializable. Okay. So question can be asked either theoretically or a schedule can be given and asked to determine whether it conflict serializable or. So since cycle present in this precedence graph, we can conclude that the schedule is not conflict serializable. So the next topic is deadlock in DBMS. What do you mean by deadlock? A deadlock is a condition when two or more transactions are waiting indefinitely for getting the locks. Okay, for example, if the transaction T1 has the lock on student data and it requests a lock for grade data. Similarly, the transaction T2 has the lock on grade data and wait for lock on request data. So now T1 will not release the lock on student until the transaction will be committed. Likewise, T2 will not release the lock on grade. Okay. So both T1 and T2 acquired one lock and waiting for another lock which can be never given. That is called waiting indefinitely. So that is called deadlock. So in deadlock, there are three categories: deadlock avoidance, deadlock prevention and deadlock detection. What is deadlock avoidance? So avoiding the condition for deadlock. When a database stuck in a deadlock state, it is better to avoid the database rather than aborting or restarting the database. So deadlock avoidance mechanism is used to detect any deadlock situation in advance. Okay, so a wait for graph can be drawn to detect the deadlock situation, but a wait for graph is useful only for smaller database. For database, deadlock prevention method can be used. Okay, so in deadlock detection, next one is deadlock detection. So in a database, when transaction waits indefinitely, then the DBMS should detect whether the transaction is involved in a deadlock or not. So it should maintain a wait for graph to detect the deadlock cycle. So if there is any cycle in the wait for graph, it means that deadlock occurs. Deadlock prevention means for large databases, if the resources are allocated in such a way that deadlock never happens, then deadlock can be prevented. Okay. So these are the three categories of deadlock. So that's all about the third unit. Thank you.